we are out of room actually. Anyway, this question was brought to me by my friend, McKay. So we are not yet done anyway. But I just want to tell you guys, it's not my idea. So he brought it for me to simplify it. It took me a lot of weeks to actually figure it out. So this is what you get anyway. So thumbs to McKay when we are done solving. Okay, hello guys, and welcome to my channel. Now in this video, we want to integrate this very complex function, the exponential of sine of x times secant of x dx. Alright? So we want to find the antiderivative of that function. Anyway, this is not very simple like that, but it is very nice, okay? It is quite fun. Alright, well, when let me start with this, that when we have the antiderivative, when we have the integral of e to power t divided by t, the t, okay, when we want to integrate that, the t, then we're just going to have the exponential integral of t, then we add an arbitrary constant to that. So I know that when I get this, okay, we will try to get it in this form, or the antiderivative will be of this form. So when we just know this, then we can just use this pattern and get the result immediately. Okay, anyway, let's just start at once. Well, from the given function, I put it down, the integral of e to power sine of x. You know that secant x is the same thing as 1 over cosine of x. So in place of secant x, I would just like to put it down, 1 over cosine of x, and I put down the dx like that. So this is actually the denominator, right? Okay, so the next thing I would like to do is to multiply the numerator and the denominator by cosine of x. Now this is what we will get. We will have e to the power of sine of x times cosine of x divided by, let me just clean this and put it down. This is the one I'm just multiplying right now. It is cosine of x, right? So divided by, this is the original cosine. In fact, it doesn't matter. This is cosine of x. The reason is I'm multiplying top and bottom by cosine of x, so I have actually not changed it, alright? Because this and this I can just cancel out, alright? And we would be left with what we had initially. Okay, so this is it. Well, the product of these two guys is going to be cosine, let me put it down here, cosine of squared x, right? You know, cosine of x times cosine of x is the square of that. Okay, very nice. Now look at this. This is the same thing as 1 minus sine of squared x, alright, from trig identities. So we know that cosine square x is the same thing as 1 minus sine square x. And again, if we have 1 minus, okay, let me not put 1, let me put something. When we have a squared minus b squared, okay, so we have difference of two squares. Figure this one as 1 square. You know, one is the same thing as 1 square, so it is 1 square, right? Let's speak it like that, so that we will be having difference of two squares where the sign has been squared already. These can be factors, so the factors are a minus b and then a plus b. Okay, very nice, like that, alright? Okay, so since these are the cases, or since this is the case, that is the factors, so in place of a square minus b square, we can just put this down. So that's what I'm going to do here actually. I'm going to put down 1 minus sine x times 1 plus sine x. So you pick them without their squares, you subtract the second from the first, and then you add them together like this. So that means that in this whole place of cosine of squared x, I'm going to put these down, alright? So let me just clean that up. And now put down 1 minus sine x, then I put it again with 1 plus sine of x. Okay, great. Now, that is what we have in the bottom. So maybe I just clean this up and we'll continue over here. The next thing I'd like to do is to go ahead and multiply top and bottom by 2. That is to say, multiply 2 to the top and multiply 2 to the bottom, so that they will just cancel out. Now, I'm actually multiplying that 2 because I want to split something here. So let's just look at it. So I'm going to have the integral of e to the power of sine of x, then cosine of x, and we put down the dx, then divided by, well, 1 minus sine x, then 1 plus sine of x, like that, alright? So like I said, we multiply the top with 2, okay, so we multiply the top with 2 and we divide it by the 2, so this is the way I choose to put it down. Okay, so we multiply the top with 2 and we go ahead and divide it by the 2 so that they will just cancel out. Now, you know that 2 is the same thing as 1 plus 1. So in place of the 2 here, I'm going to put down 1 plus 1. So we are going to split that numerator into 2 parts. Okay, very nice, like that, alright? So this is going to be 1 over 2. Then put down the integral of 1 plus 1 in bracket. Okay, so we now put down the e to the power sine of x, then cosine of x divided by 1 minus sine x, then 1 plus sine of x, and we put down the dx like that, alright? Okay, great. Well, the next thing I will do to that 1 plus 1 is to subtract and add sine of x to it. So I'm just going to do addition by 0 in this bracket. Now, this is it. This is 1 plus 1, alright? So I subtract sine of x and I also add sine of x. So, negative sine x plus sine x is going to be 0, which is just going to leave us with 1 plus 1, which is going to get us back to 2, and which will just cancel out and we get back to what we had. Okay, so we haven't changed anything if you want to look at it. So, I can rewrite this as 1 minus sine of x, then plus 1 plus sine of x. Alright? Okay, very nice. So, this is the form I'm going to put back in this place. Okay? And when I put that down, I would like to split this into 2 parts instead of being 4. So, this is the way I would like to put it back right there. So, we're going to have 1 over 2 times the integral of, so I'll be writing 1 minus sine of x, then plus 1 plus sine of x, then we multiply everything there with this, which is e to the power of sine of x, then times the cosine of x, and we put it down over the x variable, and in the bottom, we are just having 1 minus sine x, then times 1 plus sine of x, and that is it, alright? So I've rewritten it, so I just clean it up. Okay, great. Well, we've reached this point. Now, at the top, we can see that I will multiply this with this first part, okay? And I will also multiply it with this second part. That means we're going to be having, I can split the fractions actually. You know, this is going to be this plus that, putting down the same denominator. So I will go ahead and split the fractions immediately as I put down the same denominator, remembering with the dx. Okay, so this is going to be 1 over 2, then the integral of, this is going to be 1 minus sine of x, and then multiplied with e to the power of sine of x times the cosine of x dx, divided by the whole of that, that is 1 minus sine x, right, times 1 plus sine of x. We add it with, the next thing is to multiply this with that, you know, just multiplying with everybody in the bracket. So this will now be 1 plus sine of x, then we put this down, this should be e to the power of sine of x, then cosine of x, and we now put down the dx, then everybody here divided by, well, divided by this, alright? So that will now be 1 minus sine x times 1 plus sine of x. Okay. Well, since we are just having two fractions at once, oh, what have I just done? Sorry, I've split them already in my head. So since we are just having two fractions at once, and we put down the dx at the end right there. Now this is just integral. We know that the integral of the sum of two functions, right, of sum of two parts, because this is actually more than one function here. Sum of two parts is going to be the sum of the integrals of those parts. So I would like to go ahead and put down the dx here, and now add it with, I'll now bring this 1 over 2 and the integral sign. Alright, so this still works. What we had before, I changed it to something as this, right? So you just split the integrals like that, right? Putting the dx for each of them. Okay, great. Now here, we see that this and this will just cancel out nicely. This will cancel out with this one. And again, this positive, this plus sine x, and then the 1 plus sine x will just cancel out. And our work is going to become a little bit simple. Yeah, though we did a lot of work before coming here. So this is going to be e to the power of sine of x times the cosine of x, and then divided by 1 plus sine of x, and then dx. Alright, so we put it down with 1 over 2 times the integral of this, and this will just cancel, so we're left with e to the power of sine of x, then cosine of x dx. Then at the bottom, we just have 1 minus sine of x. Yeah, we are out of room actually. So at this point, I'm going to have to clean a part of the board, right, to some point, so that we can actually continue the journey. Now, this right here on the top is the same thing here. Okay, so I can just clean this up. All right, so let's just continue anyway. We see this and we see that. Well, if we make a u-sub for the bottom, we're going to have the derivative of this bottom is going to be 0 plus cosine of x dx, all right? And this is cosine of x dx. That would be a nice substitution. But unfortunately, that is not what we have on the top. Remember, we started with this, that the integral of e to the power t over t. So I am going to try to get the exponent, the t, and then the denominator to be the same. Okay? So to get plus 1 here, because that's just what we need to get the same, we need to multiply the top with e, right? Because this is just the base e, so that we're going to increase the power there by 1, by just adding 1, all right? That will make the denominator and the power to be the same. So I'm going to multiply the top with e, but I have to divide that e. So this is going to be, this is 1 over 2, just put it down, 1 over 2, then e in the bottom, because I have to divide it. Then I multiply the top with e. This is going to help us to get sine of x plus 1. Then I put down the cosine of x dx like that. Then the base with just 1 plus sine of x. Okay, so I'll still apply the same thing here, but this one, I need to get, okay, this is 1 minus sine x. I need to make the denominator to be the same as the power. No, I need to make the power to be the same as the denominator. So I will need to, well, I want to change this to become sine x minus 1. That means I need to multiply this by negative 1. Okay, so if you multiply it by positive 1, that is going to be negative times negative 1, alright? Negative 1 times negative 1 will give us positive 1. So I'm going to multiply this fraction, that is the denominator, with positive 1, that in this form, negative 1 times negative 1. So doing that, we're going to have negative 1 over 2, then the integral of e to the power of sine of x, then the cosine of x, and we put down the dx like that, right? Now at the bottom, well, I have multiplied this by negative, which wasn't so I need to still multiply again by negative in the bottom. So this is going to be negative 1, then positive sine x. So I can rewrite it as positive sine x minus 1, alright? So that is it. So we just clean this up, and we're going to enter with something very nice anyway. So like I said, we need to get minus 1 here. That will be by dividing the top by e, alright? So if we do that, we're going to have 1 over 2e, then the integral of e to the power of sine of x plus 1 divided by 1 plus sine of x. I put down the cosine of x dx, then minus, so since I'm going to do a division on the top, I have to I have to multiply. So this is going to be e to the power sine of x divided by e, then I need to multiply by e to balance it, alright? So this is going to be the e here. So the e here over 2, then the integral of e to the power of sine of x minus 1, then the cosine of x, and we put down dx, and then divided by sine of x minus 1. Okay, so we've now reached the point where we just have to apply this, and this is going to be 1 over 2e on the bottom, 2e on the bottom, then, well, let me just apply it immediately. This is going to be the exponential. In fact, let me show you guys all the steps. Instead of just substituting that, okay, let me just show you everything. Let's make a u-sub in this part. So we say, let u be sine of x plus 1, then the u will now become cosine of x dx, right? No, differentiating sine x, we're going to have cosine of x. So this right here will become 1 over 2e times the integral of e to the power of sine of x plus 1, which is just there, that is u, alright? Because we are saying u should be sine of x plus 1. Then the denominator we are having the same thing, sine of x plus 1, same thing as sine of 1 plus sine of x, so that is just u. Then cosine of x dx is du, alright? Okay, so we say minus, well, let me just make a substitution for this one also. So let v be sine of x minus 1. That means that dv will now become cosine of x dx, alright? So I will still do the same thing. This is going to become e to the power e over 2 times the integral of e to the power of v divided by v. Then we now put down dv like that, alright? Okay, great. Very nice. Now, we see here that we're going to have 1 over 2e. Now, based on this, this is going to be times the exponential integral of... Now, since we are dealing in terms of u, I'll just put down the u here, right? Okay, great. But I would like to just substitute it at once. Since u is sine of x plus 1, we just put it down. Sine of x plus 1, right? In place of u, here is t, in place of u for this one. Okay, so this is minus e over 2, then the exponential integral of v, alright? So what is v? Sine of x minus 1. So we just put it down. Sine of x minus 1. Okay, so we just have to add an arbitrary constant. Let me put it c. And that right there is the antiderivative of this given function. Wow. Okay, so this is pretty nice. Okay, anyway, thanks for watching. And besides, kudos to Make. This question is actually from him. I believe we'll be very happy to see it. Anyway, okay, thanks for watching and please subscribe to my channel.